have the 2016 question 9. This is junior cert higher level. This is paper 2 and this is a question on geometry, and this also incorporates area and volume. So a shape is made by placing a small cube on top of a larger one as shown. The cubes have edges of length 1 unit and 2 units. Find the total surface area of this shape. So if we want to get the surface area, so the surface area is, say, if we were to say put wrapping paper all around it, what area of wrapping paper would we need to go the whole way around? So we're told that the cubes, so the edge of the large cube is 2 and the edge of the small cube is 1. So generally, if we want to get surface area of a cube, we just have to get the area of one of the sides, and then we can see we have 1, 2, 3, 4, 5, 6. So we have to then multiply that area by 6. So the only thing about this is the area of the bottom of the small cube is not included in the surface area, and that part of the big cube isn't also included in the surface area. So if I want to get the surface area that the small cube would kind of take up, we kind of have to wrap around the small cube. If we were to wrap this, say, well, yeah, if I get the area of one of the small cube, so area of one face of small cube, well, the area is just going to be the length by the width, and because it's square, the length and the width are the same, so 1 by 1, so it's just 1 unit squared. And we can see that how many kind of faces are exposed. So we have 1, 2, 3, 4 and then 5, so the one on top, so 5. So the number of faces we can see, number of exposed faces multiplied by 1, which is the area of one face. So then we get 5 units squared is the surface area that the small one takes up. And what I can see is I'm going to leave the top one of the larger one till last, but first I'll get the area of one whole face of the larger one. So area of one face of the large, so that's going to be 2 multiplied by 2, so 2 by 2, so I get 4 units squared. So if I want to get the amount of, say, full faces that are exposed, so I have 1, 2, 3, 4, so 4 all around the side and then 1 on the bottom, so that's going to be 5, so 4 by 5, so that gives me 20 units squared. But the area of the top one is going to be equal to the area of the larger one altogether. Subtract the area of the face of the small one. So the area of the large one is 4 on the top, and the area of the smaller one on the top is 1. So to get the area that's actually left, it's just going to be 3 units squared. So the area that the large one actually takes up is going to be 23 units squared. So if I want to get the total surface area of this shape, it's going to be the 23 units squared that covers the large, and then the 5 units squared that comes from the small. So 23 plus 5, so that gives me 28. So the total surface area of this shape will be 28 units squared. So I can write units squared. And then, so the next part, part B, I'm just going to fold this over so you can see it. So so the line segment AB, so we have a line segment here, and we're calling this, so this is a straight line. My diagram is just a bit off. So the line segment AB, so it says, is a diagonal at the base of the shape as shown. Find the length of AB. Well, this bottom square here doesn't look like a square at the moment because it's kind of slanted, but that bottom say is a square. It's really a square with lengths of 2. So this is 2, this is 2, 2, and 2. Doesn't look like a right angle at the moment, but we have to remember that because it's in 3D, it doesn't particularly look like a right angle, but it is in fact a right angle because the bottom is a square. So I can use Pythagoras to get the length of the diagonal. So if I was to use, let's just call it x for now maybe. So x squared is going to be equal to 2 squared plus 2 squared. So Pythagoras says that hypotenuse squared is equal to the sum of the square of the other two sides. So x squared is going to be 4 plus 4. So x squared is going to be equal to 8. And then if I want to get what x is, I have to get the square root of both sides. So x is going to be the square root of 8. But if I plug the square root of 8 into my calculator, I'll get 2 root 2. And how they got that is that I can write the square root of 8 as the square root of 4 multiplied by the square root of 2. And because I can actually work out the square root of 4, which is 2, I can write it as 2 root 2. So x is going to be equal to 2 root 2, and really they called it AB. So AB is equal to 2 root 2. So that's the length of my diagonal. And then the next part of the question is, so the right angle triangle, so they're after constructing, so this is A, B, and then I have a C up here. So the right angle triangle ABC, so we have ABC. So I'm already after getting what AB is, and I think that might be useful in the next part. So I'm just going to write that this here is 2 root 2. So we're asked to find BC. So we want to get BC. So we want to get the length of the diagonal. So we have to try and remember that this is in fact, because it is square, it doesn't look like it's a right angle, but this here is actually a right angle triangle, even though it doesn't look like it. It's just because it's 3D and it's kind of put out a bit of a slant. So this triangle, we can redraw that to make it look like a right angle, because it is in fact a right angle. It's just the model that kind of puts us off. And we know that base is 2 root 2, but we know this length is equal to the length of the side of the larger square plus the side of the smaller square, and the larger square has a length of 2, the smaller square has a length of 1, so the total length is going to be 3. So then BC is going to be, we can use Pythagoras again, so let's call this y. So y squared is equal to 3 squared plus 2 root 2, and that's squared, so y squared is equal to 9. So if we square this, if we square 2, we'll get 4, and if we square this the root 2, the square root will cancel, so we'll get 4 multiplied by 2. Or I can plug it into my calculator if I'm not sure. I can plug in 2 root 2 and just to make sure to use brackets, and I get 8. So 4 multiplied by 2 there, we'll have 9 plus 8, so y squared. So y is going to be equal to, y squared is going to be equal to 17. And then if I want to get what y is equal to, I have to get the square root of both sides. So y is equal to the square root of 17, and that won't simplify down any further. So the diagonal here is equal to the square root of 17. And then the next part, I was asked to find the length of the part of BC. So find the length of the part of BC that is inside the larger cube. So what I have to do now, so I'm just going to draw out my triangle as a right angle triangle to help me understand it a little bit better. So what I can do is, I'll just, so sometimes in this situation I think it can be very helpful to draw what we have, what we know. So we know that is in fact a right angle triangle because this is a square, the bottom is a square. So this is in fact a right angle triangle. and we want to figure out the part of BC that is inside the larger cube. So say if I draw kind of a cut off at the where it kind of cuts into the smaller cube. So say I know that the length up to the larger cube is 2, and then the rest of it is 1. I know that the bottom length is 2 root 2, and I'm after figuring out that this whole length here is root 17. So if I want to get, so this is a right angle triangle. So firstly, even when I see something like this, I'm kind of thinking similar triangles. So what I actually want is the part of BC. So this here is BC, so this is A, this is C, this is B. So I want the part of BC, so this part here, that is inside the larger cube. So I just want this here. So what I can do, if I have, with similar triangles, say if I had these two triangles, so actually what I might do is I can draw them into 2 different triangles. So these ones here, this here, and this here. So this is a right angle, this is a right angle 1, this is, the whole big triangle is 3, and the whole length of this is square root of 17. These triangles are similar because they all have the same angles. Because this is a straight line, this is right angle straight across, this is just a straight line. These lines are parallel to each other because it's just cutting off at the top, the end of the square. So these lines are parallel, so these would be corresponding angles, and similarly with these. So these triangles are similar triangles, so I can actually use similar triangles to find the length. So the first thing that might be easiest to do is to get the length of the side that's inside the smaller triangle and then take that away from the square root of 17. So I can put the length of the smaller side, which is 1, over the length of the whole of the bigger side, which is 3. So the whole of the big triangle altogether. Because this bit here isn't a triangle in itself, so I'm just going to have to treat. So I'm taking 2 different triangles. So I'm taking this as my small triangle, and then for my bigger triangle I'm taking the whole length here. So I'm comparing these 2 triangles. So this is my smaller one, this is my bigger one. I'm going to first get the length from here to here, and then I'll subtract that from the square root of 17. So if I want to get, I can put the length of the small one over its corresponding side, which is 3, over the length of this small one over its corresponding side, which is the square root of 17. So if I want to get x by itself, I'm going to have to rearrange this a little. So the first thing I might do is multiply both sides by 3. So if I multiply this side by 3 and this side by 3, I'll have 3 on the top and 3 on the bottom, so they will cancel. So I get 1 is equal to 3x over the square root of 17. And what I now might do is multiply both sides by the square root of 17. So the square root of 17, the square root of 17. So now these will cancel here, and I'll be left with the square root of 17 is equal to 3x. So if I want to get what x is by itself, I can divide both sides by 3. So x is equal to the square root of 17 over 3. But that what I got, x was the length of the smaller side. So if I know the whole length, so if this is the square from here to here is the square root of 17 over 3, I can do the square root of 17 to find the length of the larger one. It'll be the square root of 17 minus the square root of 17 over 3, and I can work that out myself, or I can do it out in my calculator, and I'll show you how we get that. So the square root of 17 minus the square root of so we have the square root of 17, so I just have to pressing something, square root of 17 minus the square root of 17 over 3. And that's how I plug it into my calculator. So I get 2 root 17 over 3. So that's the length of the part that's inside the larger cube. And it doesn't say what units to leave it into, but I might leave my answer in third form, or I can put it in decimal, but it won't, I'll have to round it. So I can say is equal to this, or I could say is equal to 2.75. So I have the option of leaving it in third form because it doesn't actually specify which form I should leave it in.